Okay, so we also want to find both f of g and g of f of both of these functions and their domains. So first up, if we look at f of g of x, that's f where we plug g of x into it. So that's f of 3x squared plus x, which is 2, and we replace x, so 3x squared plus x minus 5, which gives us 6x squared plus 2x minus 5, and that's f of g of x. So the domain of this function, remember you look at it kind of on its own merit initially. So this function on its own, its domain, is the set of all real numbers, right? This is a parabola, or it's a quadratic equation, I should say, and its domain is all real numbers. We can plug in whatever we want. Remember, we do need to also consider the domain of the interior function. So we need to go back here and look at g of x. The domain of g of x is also all real numbers, so that does not change this domain at all, and that is part of your final answer. So if we reverse this and we look at g of f of x, right, that means g is the outer function, which means we're plugging in 2x minus 5 everywhere you see an x. So 2x minus 5 squared plus 2x minus 5, okay? So if we clean this up, we get 4x squared minus 20x plus 25 plus 2x minus 5, and you get 12x squared minus 60x plus 75 plus 2x minus 5. So you end up with 12x squared minus 58x plus 70. Okay, and again, you'll see that the domain of this function is not super interesting. The domain so far is negative infinity to infinity, and we'll see if there's anything else we need to take out. And I would say the answer to that is no, because this is a linear function, our interior one, right? And its domain is all real numbers. So there's no change, and that is our final answer for its domain, right? Again, we can plug in whatever we want. There are no restrictions on this function.